My camera keeps not wanting to focus. Sorry about that. Okay, so I'm going to restart this. Okay, so this is a butterfly net, and we have a electric field that is going through the net, and it is 150 newtons per coulomb. And then the circular loop, which is where we are measuring from, has a diameter of 400 millimeters. And so I took the area of the circular loop, which is pi r squared. And we have, we're going to find the electric flux, as well as, see, it's still not focusing very well, sorry. We're going to find the electric flux, as well as answer if the flux is increasing or decreasing if we were to rotate so that it lies in the vertical plane. That's an S. And so I'm going to take and plug in d over 2 to my r, which gets me pi d4, so d squared over 4. And we're going to plug that into the electric flux equation. Because they're in parallel, meaning that there is a 0 degrees between the n, because we're measuring downward, so n hat is parallel to electric fields, so we don't have to worry about cosine in this portion. So we're going to take the electric field, which is 150 newtons per coulomb, and we're going to multiply it by pi 400 times 10 to the negative 3 meters squared divided by 4. And that is our electric flux. And so let me put that in here. 150 times, times 10 to the negative 3 times pi divided by 4. Did I do that right? Ooh, I forgot to square it. That's why. Okay, so restart here. Divided by... Okay, so I get the electric flux to be 18.8, and that's going to be Newton meters squared per coulomb. So units are good. So that means I'm kind of on the right track here. And so that's the electric flux through the net, which was the first part of the question. And so then it said, if the circular loop is rotated in a vertical plane, meaning so it's meaning so that it's now vertical, which would mean that the cosine function would decrease because of the angle. So the angle would cause a decrease as you rotate it. So based on that, if the cosine function is decreasing with the angle, we can say that the electric flux would then decrease because of relation to cosine theta function decreasing. I used a down arrow as shorthand for decrease due to that relationship. And so, sorry if it was blurry, but yep, there we go.